types of energies or is different forms of energies. Now you people tell me, what is the different forms of energies you people know? Different forms of energy. Anybody?
Kinetic energy, potential
Yeah,
energy.
different forms of energy. Very good. So very good, Elmukil. So you know only kinetic and potential energy. Don't know any other energy.
Sir,
Mechanical
muscular
energy,
Yes,
solar
muscular
energy,
energy.
wind
Very
energy.
good. Muscular energy. Very good. Tell me. So let me take first.
Mechanical
Magnetic
energy.
Wait. First one, mechanical energy. Very good. Yes. Next one. Second one, light energy. You can say. Next one, third one, heat energy. You can say. Fourth one, electrical energy. Next, fifth one, nuclear energy. Can I say it or not? Nuclear energy. I can say next one. Any other form of energy? You don't know. That's all. You are hearing my voice. What is
Wind
the
energy, solar energy.
Yeah, sound energy. You can take solar energy. Very good. Next main thing, battery, dry cell. Dry cell, something will happen. What is that energy? Chemistry behind.
Chemical energy.
Yes. What is that?
Chemical energy.
Chemical energy. That is what people should speak. So what is that energy? Chemical energy. So these all are different forms of energies which we have been already studying from the lower classes. So again in this class 9th also, this all the energies we will study again in the case of a concept called as transformation of energy. Understanding? So transformation of energy that we will study in the later classes. So later classes means in this class 9th only. But now in this chapter, in this work and energy chapter, we will study mainly only one form of energy. That is only we used to called as mechanical energy. What is that energy, guys? Mechanical energy. So what do you mean by mechanical energy? This is the most important energy which we will study here. That is what mechanical energy means. A mechanical energy is to represent with a ME, or you can write with a U also. So mechanical energy is a combination of two energies. That is what kinetic energy plus potential energy, which we used to call as mechanical energy. Okay, guys, everybody. Yes, please respond. That is what you have to understand. Is it okay, Laksha? So now in class 9th, majorly we will focus on this kinetic energy and as well as potential energy only. So now let us discuss what is this mechanical energy and in detail what is potential energy and kinetic energy we'll study. So now as we know, already we studied work done. What is the work done formula, guys? Work done is equals to what? Force into displacement. Now, when we are working against the gravity, we know that by the time what is the work done? Work done is equals to force into what? Mass into acceleration due to gravity into height we are working. Height. So this is what? The formula for work done against what? Against
Gravity.
Gravity. This is what we did it. Is it okay, guys? Will you remember that? Adarshan, Darun? That is. So now if you notice it, let us come to the kinetic energy. So always you remember, guys, kinetic energy is the energy possessed by a body. Energy possessed, understanding? Possessed by a body due to its motion. From what, guys? Due to its motion. Understanding? So a body energy, whatever the energy possessing due to the motion, that energy we used to called as what energy we used to call, guys? Kinetic energy. Understand, everybody? Yes or no? Please respond. Next, due to its not rest means zero, no energy is possessed. Due to its state of position, what is that? State of position, the energy acquired by a body is only called as what we used to call, guys?
Potential energy.
What is we used to call potential energy. So means due to the energy acquired by a body or possessed by a body due to its position is called as potential energy. Due to its motion, what energy we used to call? Kinetic energy. Understand? So now for our today's class, we will study what is this kinetic energy and how to derive the formula and all. And the next class we'll continue with the numericals and as well as potential energy. Now, so let's start with the kinetic energy. Everybody, are you ready? So now,
Yes, sir.
kinetic energy, very simple and simple way I will say you. So now let us see what is going to happen. So now, kinetic energy. So what do you mean by this kinetic energy means? It's very simple, guys. If you notice it. So now, if you'll see, it is acquiring the energy acquired by the body due to its what, guys? Due to its what? Due to its motion. Understanding?
Sure.
Energy acquired by a body due to its motion. What we used to call? What we used to call, Ra?
Kinetic
Energy
energy.
possessed by a body due to its motion, we used to call it as what? Kinetic energy. Now, this kinetic energy, which is equals to, the formula is half into mass of the body into velocity square of the body. Understanding, everybody? Square of velocity of the body. So this is what the formula of kinetic energy. What is this, guys? Formula for calculating kinetic energy possessed by a body. So now let us understand the derivation. Very simple derivation I will take. Okay. And I will make you to solve it also very easily. You people can solve. Now let us understand, everyone. So let me take a certain body. If you have not understand, you ask me. So now which is at position A. What is this, Ra? Which is at position A, having some mass. Having, what is that, Manish? Having some mass, and it is moving with the velocity. It is moving with the velocity small v. Let me take. This is what the velocity possessed by a body. What is the velocity? Pradosh?
Small v.
Small v. Okay, Mukesh Karthik. So velocity possessed by a body is v, and it is at position A and having what, guys? Mass m. Now, suddenly it is entering into some medium. This is what? Let me imagine the medium. What is this, guys?
A
What?
medium.
Medium. So what do you mean by medium? You know that air or any other medium. Now, for example, if you people will hit the ball with the bat. Now, if nobody is stopping, is it the ball will be in continuous motion? Is it ball will be in a continuous motion? Please respond.
Sir.
Yes. Elamokil?
Yes, sir.
Is it the ball will be in a continuous motion, or it will, after traveling certain distance, automatically it will come to rest?
Sir, it will come
Sir,
to
Automatically it will
rest,
come to
Why?
to rest.
Because when it is traveling in a medium called as, what is the medium? It is air. Yes.
sir.
Now here two things will happen. What is that? One is air friction will takes place. Friction of air. Yes or no? Air also will causes friction, and also what will causes friction? Another friction. Ground also
Gravity.
will causes friction. Yes. So always we know that friction is always acting what? Opposite to the direction of motion. Is it yes or no, guys? Yes, please. Yes.
Yes, sir.
So now if you notice it, when the body is traveling in a particular medium, suppose see, this body is already traveling with what? Some velocity v, which is having with at position B. Now, when it is entering into the medium, now you tell me, when it will entering into the medium, then definitely some frictional force is acting continuously opposite direction. Yes or no, guys?
Yes, sir.
Yes or no? Please respond, everybody. So let me take till medium is here. Is it okay, Pradosh?
Yes, sir.
Yes. So that is what you have to understand. So now the body is entering into a certain medium, then the continuously some backward force, that is what the frictional force is opposing on air, and slowly its speed will decreases or increases. Monish?
Decreases.
Keep on
Decreases.
decreases, but still it will travel some distance. And finally it will reaches to a point B. Where it will reaches, guys? For point B, and speed keep on decreases. What is the final velocity, guys? What is the final velocity? Final
Zero.
velocity, what it is that?
Zero.
The final
Zero,
velocity
sir.
become 0 meter per second. This is what? So mass is same. Now you can notice it. Now you tell me, what is the work done to travel to travel this distance from A to B against to this force? So what is the work done? The total work done to travel S distance against to force, I can say work done is equals to, what is the formula? Work done is equals to force into displacement.
Displacement.
Yes or no, guys? Yes, please respond. So now, whatever the work done by this body against to this force to travel this distance, which is equals to what? Elmukil, Pradosh, anybody? Which is equals to what? Energy possessed by a body. Is it yes or no?
Yes, sir.
Yes, guys. Possessed by a body. So now, the energy possessed by a body due to its motion, which energy we used to call? Which energy?
Kinetic energy.
Kinetic energy.
Kinetic energy.
Energy. Do you understand? So, whatever the energy possessed by a body against to this force to travel this s distance, that is what is equals to work done. So, can I say work done is equals to kinetic energy? Is it okay, guys?
Yes, sir.
Yes, sir.
Yes or no? Please respond. Laksha, have you understand? Work done is equals to kinetic energy. Now, you can say from that means in the sense of kinetic energy. Kinetic energy is equals to, can I replace with that force into displacement? Is it any right or wrong?
Yes, sir.
Yes. Darun, have you understand displacement? So I can say kinetic energy is equals to F into S. Any doubt, guys? Let me imagine this is equation 1. Okay, guys? Clear, my
Sir.
train?
Yes,
My
sir.
train, any doubt, my train? Mani and Samaya, till here? Kinetic energy is equals to force into displacement. Now you tell me, body is already having some velocity V. This is what velocity we used to call as initial velocity.
Initial.
Understand? Initial velocity, and the final velocity becomes 0 and it is traveled some distance. Yes. Now you tell me, velocity and position. Which equation, guys? Velocity and position.
The third equation.
From third equation of motion. Very good, Monish. Third equation of motion, we can say, what is the third equation? V square
P square
minus
U
U square,
equal
which
to
is equals to
2s.
what? 2as. Is it?
2as.
Yes. Now you
Yes,
can,
sir.
from the given figure, we can say initial velocity u is equals to what? V. Yes or no? Yes. Now let final velocity V is equals to capital V. Is it okay? Any problem, guys? Next, acceleration. Tell me, acceleration is decreasing acceleration or increasing acceleration?
Increasing.
Decreasing acceleration. Decreasing acceleration means plus or minus. It is condensed.
Minus.
Kindly kept to rest. Means in the sense of what it is. It is retardation. Yes or no, guys? Yes, please respond. That is.
Yes, sir.
So A equals to minus A now, and as well as distance traveled. What is the distance traveled? Distance S is equals to S only. Now substitute all these values in third equation of motion. Let me imagine this is equation number 2. Now substitute in all the values in equation 2. Substitute small u, capital small V, and as well as A in equation 2. Now what will come, guys? Tell me. Equation 2 is what? V square minus U square is equals to 2as. Now, as we know, V square is equals to what? Capital V square minus small u means what? Small v square, which is equals to 2as. Yes, Ra? Please respond.
Yes, sir.
So now, A equals to what? Minus A.
Yes, sir.
Minus A. Now, as we know, what is the final velocity? Final velocity will become what? 0 meter per second. No, guys, so that this full term will get cancelled. Any doubt?
No doubt.
Is equals to what? V square is equals to minus 2as. Till here, any doubt? Anybody you can ask.
No doubt.
Minus 2as.
No, sir.
Yes, please. Alana, now you can check it. Now you can see the body is moving from medium, so that if velocities keep on decreases. So that is why I can take acceleration is equals to what, guys? Minus A, because
Minus U.
increasing acceleration, so that minus A it will come. So if we'll take it here, then what will come? Both the sides minus will get cancelled. So what we used to get, guys? V square is equal to 2AS. Yes. Now let imagine this is equation 3. What I can assume, Monish? Equation 3.
Equation 3.
So any doubt, anybody, you can ask me till here. So now try to understand. This is very important derivation also. Now, from Newton's second law, let me say, girls will say, from Newton's second law. Can you say Newton's second law, anybody? Anybody, girls? From Newton's second law. Girls, I am asking. So what is the Newton's second law? Force is equals to
Force is equal to mass into acceleration.
acceleration. Yes or no? Now, from that acceleration is equals to what it is? Anybody?
Force by mass.
Force by mass.
By mass. Don't say force into mass. Understand? Very good lecture. So now let us imagine this is equation number 4. Now you might be understand by this time. Substitute equation 4 in where? Equation 4 in equation 3. So what is equation 3? V square is equals to 2AS. Okay, guys. So V square is equals to 2 into A into S. Now in place of S, A, what I can substitute? Draw. In place of A, what I can substitute? F divided by M into S. Is it okay, guys? Yes or no? Now,
Sir.
M is in division. Will come this side. What will become, Elmokel?
Multiplication.
Multiply.
V square into M.
M into V square, which is equals to 2 into F.
of S.
Yes or no? Now, 2 is in multiplication. Will come this side. What will become? What will become?
Division.
So now I can say half into M into V square, which is equals to F into S. Is it okay, Adarshan? Have you understand? Darun?
Sir, F into S work done.
We know SS. We know from which equation? From equation 2, I think. Equation 1, correct? Equation 1.
One, sir.
So what is that? Force into displacement is equals to work done. Work done is equals to what? Kinetic.
Kinetic energy.
Kinetic energy is equals to half into M into V square. This is
M
what.
into V square.
Yes, sir.
Okay, guys. So this is F into S is equals to what it is? Kinetic energy. So which is equals to half mv square. This is only the formula for calculating kinetic energy of any body. Have you understand the derivation or not? That is what my question. Okay, guys. That is. Now I am showing you from the first. Anybody is having any doubt, you can ask me and start doing now. So kinetic energy. Definition you write first. Definition. The energy of a body. The energy of a body. The energy of a body due to its motion. The energy of a body due to its motion. The energy of a body due to its motion. Due to its motion. The energy of a body due to its motion is called kinetic energy. Is called kinetic energy. Next, formula for kinetic energy. Formula for kinetic energy. First point you write. The kinetic energy of a moving body. The kinetic formula for kinetic energy. Formula for kinetic energy. And you have to write. The kinetic energy of a moving body. Kinetic energy of a moving body. Kinetic energy of a moving body is measured by the kinetic energy of a moving body is measured by the amount of work. Kinetic energy of a moving body is measured by the amount of work it can do before coming to rest. It can do before coming to rest. It can do before coming to rest. Very important point. Now from here, you people can proceed. What is the diagram you have to draw first? This is the diagram you have to draw. Understand, draw? So before I enter into the medium, velocity is V and position B, position A. Finally, it reaches to position B, means in the sense of what? coming to the rest. So final velocity is 0, initial velocity is v, and it is entering into some medium m, so that it is continuously decreasing acceleration because continuously opposing force is acting f. So that is what the diagram you have to do. So here you put a statement. That statement I will say you, the statement only you have to write it now. After that formula you can write it. Okay. So that statement, right? In going through the distance, yes. In going through the distance, yes. In going through the distance, yes. Against the opposing force F. Against the opposing force F. Against the opposing force F. Opposing force F. The total work done is the total work done is, comma, you can keep. After that, you can proceed from here. Is it okay, guys? Draw the diagram and ask me anything. Karthik, have you understand, Karthik? Alana? Darun? That is. Maitrayan? If any doubt, anybody you can ask. So this is what. So now from here, you have to proceed. So work done is equals to force into displacement. Next, what will come, guys? After that, force into displacement after energy possessed by a body, which is equals to what? Work done. That is what? Kinetic energy. So kinetic energy you can take, you can imagine kinetic energy is equals to force into displacement. So you can proceed from here neatly. Is it okay, guys? Any doubt you can ask me, I will help you. No problem at all. Again, I will want to teach also, I'll teach. But very, very important derivation, I am saying you. So kindly do it. Once it is completed, you can tell. That is. This is all from here. We'll see later. We'll continue. And you can learn this carefully. So it will be helpful. Definitely it will be helpful for us. So we can improve also. That is what. So tomorrow we'll solve the next continuation of this kinetic energy and as well as numericals. Later potential energy, later transformation of energy and energy conservation. That's all. That chapter will be over for our exams. So hardly we'll finish within 4 or 5 days. Later, next till the exams we'll practice only. Next week and all. So that is what you have to remember. Is it easy or difficult, Ira? Monish?
Easy, sir.
Yeah, very easy only actually it is. But people will face difficulties in derivation. But that is what very simplified way I am saying you to better understanding. That is what. It's most simplified way I am saying you. Yes. SL mobile. Okay. So solve this one, everyone.